Good morning, everybody. A fun problem that's quite similar to a Pan African Math Olympiad back in 2001. Now we are looking for a negative integer, and this is a fancy way of saying that. It says any integer less than 0 is what this superscript less than 0 means. You could say just more tersely n is less than 0. Now we want such an n, we want a negative n such that this quotient is also an integer. Now one that you can spot by inspection really quickly would be n equals 2, but it's not negative, but let's verify here. For n equals 2, that implies 21 over 21. It's an easy computation. And this is trivial, but it still meets the requirements. Okay, 1 is a proud member of the integers, right? Z. So 2 is a solution here, as you can see when you substitute here and here. 8 plus 23, and then 4 plus 17 is 21 over 21. Okay, we're looking for a negative n. Okay, so let's move along. Now, the simplest approach that I can imagine is just to do a long division. And notice that you can just, by doing plain algebra, if you multiply through this by n squared plus 17, you get cancellation and you get the left-hand side. So you don't even have to think of it as synthetic or as long division. It is, but you can see quickly that if you make a common denominator n squared plus 17, you actually just get this very quickly algebraically. Okay. Now the benefit of this is we want this circled part, which is easier to compute since it's a linear over a quadratic instead of a cubic over a quadratic. We want this to be a member of Z, right? And I should put the verb want right above that. Okay. We want the circle object to be a member of Z. Now, notice for this to happen, this expression would have to be greater than or equal to 1 in an absolute value sense. Because if it was less than 1, the numerator wouldn't be a multiple of the denominator. We need the numerator to be a multiple of the denominator. Okay, so another way of putting that a little more tersely is that we want the absolute value to be greater than or equal to 1. Now, all this is just basic absolute value definitions. Literally, the absolute value is greater than or equal to 1 if if either of these two statements is true, and I won't go through that. It's just it follows immediately from the definition of absolute value. Now I'm going to just work with this one first and see where we go, okay? Because all we are is looking for a single negative solution, okay? So I'm working with this piece right here, and you get this statement right here. It's very, very straightforward to see that, okay? Now, so we get down to this point where we solve this quadratic, and it's very easy because remember it's b squared minus 4ac. Well, 17 squared is 289, and 4 times 4 is 16. 289 minus 16 is the 273 you see right here. Now, so what we're really looking at here, folks, is a quadratic. We're going to look at where it's equal to 0, then try to find out all the negative integers between there. Now that's motivated by something pretty simple. Let me draw a picture of what's going on right here. See if hopefully there's enough room here for this. Okay. Now, so actually I didn't need all that space to the right, did I? Y'all notice here that minus 17, it would be a number like if you we'll call this minus 17 right here. Okay, that point right there. Then also, right here, this is almost to 0. So you see, we know that our point, we'll put minus 1 right here. So you can see that these numbers aren't quite, it would be all the numbers between this and somewhere right around here. Let me just put the dots. Okay. Okay. So in other words, we're talking about a quadratic that would look like this. Sorry. Okay, and so you see we're looking we're looking for all the integers between minus 17 and this number. Well, but it's between these 2 points right here, folks. And notice that set of numbers would be minus 16, minus 15. To me, this is slightly better to just think about it like this than just doing the formal, minus 14. And let's get some ellipsis working here. All the way up to minus 2, minus 1. Right? Those are the only integers that would satisfy this inequality. We're not just looking for real numbers, we're looking for, it's discrete. We're just looking for the integers. So minus 16 through minus 1 would be what satisfies this inequality. And notice all you had to do is find the endpoints and then look at what was in between based on the shape of the graph, right? Okay, now of course this is far from being to scale. So we know any possible negative solutions will have to be in this set, at least for this branch of it. Okay, now, so y'all, what I did right here is I've just done some of the work already to cut down on time. You can see for minus 1, if you put a minus 1 right here, you get 30 over 18. Right, folks? If you put minus 1 here and minus 1 here, you get 30 over 18. And I've checked these, and so far none of these are, I'll say none of these are integers, right? You see, we need this part to be an integer. We need this piece. N is clearly an integer, right? But we need this piece to be an integer, right? Okay. Now, so none of these are. Now, so let's check out n equals negative 6, okay? So let's go n equals negative 6. That would give us minus 6 times this, minus 140, 6 times 17 is 112, right? Or no, 102. So this would be 115. Over, what are we doing, negative 6, 36, 53. Okay, that does it? No, 3, yeah. 5 times 53 would be 165. That's sort of in the, but 4 times 50, no, it's not there, is it? 2, no, yeah, it's not there. So this is not a member of Z. Okay, now let's try n equal negative 7. So what does that imply? 13 minus 7 times 17 is 119. So this would be 132. And what do we get here, folks? Minus 7, 66. 66, that's looking promising. Okay, that's equal to 2, right? So voila, we got it. Okay, and of course that's a member of Z. 2 is a member of Z. Right, so in other words, another way of saying that, it's a reduced fraction that ends up being an integer, right? So the answer is negative 7. Now there may be others I don't know, and I didn't even check. I didn't feel like doing all the work. But you also, so negative 7 is one answer. And I don't know if there's any more really, but if you wanted to find out, you could explore what happens on this. We just did this piece right here. We did this piece right here. But if you do this part right here, you might find some others. I'm not sure. Okay. But anyway, negative 7 is what I got. And so we'll come right up here and say n is equal to negative 7. Now, some of you may argue, that's why I'm not very careful. I didn't say find all. Okay, we found two. We found n equals 2 and n equals -7, right? And I'm not really sure if there's any others. I haven't really checked. Okay, but so that satisfies the conditions of the problems, and I think our cross between a human, or no, whatever this thing is. Ooh, I just noticed him. Okay, n equals -7, folks, is the answer.